Hey guys, so this is just a video to go over the review with you and help you prepare for your test. Remember, for purple classes it will be November the 5th, and gold classes it will be November the 6th. So that's not, that'll be the week after our kind of short fall break that we have. Alright, so first thing we're looking at is graphing the equation of a line. Here is, you always want to make sure is the equation in slope-intercept form first. So slope-intercept form is y equals mx plus b. And yes, that is in that form. So 3 is our m, or our move, or our slope, and then negative 2 is our b. So I think move, begin. Okay, so if I'm beginning at negative 2, now that is the y-intercept, so I want to make sure that I am on this line, and those negatives kind of blend in on this graph, but that would be negative 2, so y negatives up there on the bottom, I'm going to go down. Alright, and then if my move is 3, it's like 3 over 1. Since they're both positive, that's up and right. So I can go 1, 2, 3, 1, 1, 2, 3, 1. You want to make sure you're moving from that original y-intercept. Okay, I could also do the total opposite and go 3 down, 1 left. And lastly, an equals, the equation just gets a solid line like that. Okay, really what you can see for your, say for your explanation part is just something about the y-intercept, or the b is negative 2, and the slope, or the m, is 3 over 1. There's a few things you could say there. You could say like negative 2 is where you start / begin at. 3 is how you move. It's the rate of change. Quite a few things that I would accept on that. Okay, 2. Solve each system of linear equations by substitution. I would accept either route on these, substitution or elimination. These ones kind of do set up well for substitution, but I'll look at that. Alright, so the first one, when you're doing substitution, you need to get one of the variables by itself. I'm going to use this top one because y is almost by itself. All I need to do is add 3x to the right side, which would give me y equals, if I add 3x, now that's positive 3x, and that was a positive 9, so I do plus 9. I cannot combine those because they are not like terms. And one has an x and one doesn't. Okay, so now that that is by itself, I'm going to take everything y equals and plug it in here. So that's now going to say negative 6x plus 2 distributed to 3x plus 9 equals 18. Okay, distribute first. Those actually cancel out. And then I have 18 equals 18. If this happens, you want to think, is it true? Then it's infinite solutions. Not true, no solutions. So in this case, this is true, meaning this is an infinite solutions. Alright, second one, I would rewrite first by adding 5x to this side. So now I have y equals 5x minus 6. I'm going to take this part, plug into y here, and again plug into distribute. Something I forgot to say at the beginning of this video, but I would recommend using this to check your answers, so try to do it on your own first, and then come back and see how you're doing looking at this, okay? Alright, so I just distributed that out. Now I want to combine my like terms, which comes to negative 36x, and I will minus 48 from 12. So 36x equals negative 36 divided by negative 36. X equals 1. So I like to just write that in my ordered pair now, because if it has a solution, a 1 solution, I need to write it as an ordered pair. So if that's x, now I can take the 1 and plug it into either of our equations that we have. Doesn't matter which one. This bottom one is probably the easiest, and it doesn't matter if we plug into the one we rewrote or the original. I'm going to plug into the one that we wrote just because that looks simpler. So that would say y equals 5 parentheses, our x goes here, and then minus 6. All right, well that's just 5 minus 6, which gives us y equals negative 1. And final answer, that is a 1 solution systems. Okay, 3. The table shows how the number of frogs croaks per hour change with the temperature. So we have our temperature, croaks per hour, find the rate of change. So you want to look at this and see the change, just looking at the pattern really. So 20 to 40 plus 20, 40 to 60 plus 20, 60 to 80 plus 20, again, and again. Okay. Next we have looking at the per hour plus 30, and again looking at the change, not just the number. So 60 to 90 plus 30 plus 30 plus 30. Okay, and I'm going to do so I have my croaks per hour on top because y goes on top. So you usually set up x, y like that, but you need to simplify this. So that's going to simplify to 3 over 2. Remember, keep slope or rate of change as a fraction for our kind of graphing purposes. So if it's 3 over 2, that's telling us in this case, if we were graphing, we would want to go up 3 and right 2. Okay, B, is the graph of the data a line? If so, what is the slope? If not, explain why not. Okay, well, rate of change and slope are the same. So the slope is 3 over 2. It would form a straight line. So I'm going to say yes, because the change was constant. You can think or the same. So basically it went up 20 each time, that was all the same, and then 30 each time. So we make sure that's saying the same. That tells you whether or not it forms a line. Okay, so now we're looking at a system of linear equalities. So remember, a system means there are 2 equations or inequalities given, and you are looking at how those kind of intersect. Okay, you have to make sure that you have your equations in slope-intercept form first, meaning y is by itself. So their second one's good, but our first one we need to fix. Okay, so I'm just going to rewrite it over here. 2x plus y is greater than 8. I would subtract 2x, because if I'm just moving to the right, I'm just going to subtract. That was a positive 8, so I'll put plus 8. Okay, now we're good to graph it. So I'm not graphing that one, I'm graphing this one. Alright, so I'll start with this one. So take a minute and graph both of these, and then you can check your answer. Alright, just going to check on this first one, so the green matches up with the green there. Once I graphed it, this was a greater or equal, less than or equal, they both get solid line. So when I connect my points and go all the way across your graph with your points, take them as far as you can on inequalities. Okay, and the graphing part is sometimes where it gets tricky. If this means greater or equal, well, it says y is greater or equal. All the greater y's are up here because those are the positives. So that means I want to shade everything above this line. Because I'm currently at -6, that's where I started. Let me make this other line black. So if I had went down, well then I get to -7. Well, that's not greater than my starting point. So, and yes, solid line on that one. Okay, my other one, I want to begin at 8. And then my slope is -2, and I can put it over 1 if I want. That's down 2 and right 1. Make sure you don't go down 2 and left, because that would be like a double negative, which is actually a positive. Remember, I'm going all the way across my graph here. I can also go up 2 and left. Okay, and this one is greater than no. So if it's greater than or less than with no equal to, it's a dashed line. Again, I'm going to go over it in black just to make it more obvious. Okay, and then this one also says greater, so I'm going to shade kind of above here. It's kind of hard to tell on that one since the y's are sort of cut off. Okay, now the actual area of your solution is, highlight that here, area of the solution is all of this overlap area right here. So it's where both of the colors are happening. Yeah, that's better. Okay, so only in this part, all right? I could also do if it falls along this solid line that's within there, or the dashed part here wouldn't count because it's dashed and it doesn't include those numbers. Okay, so what I want to do now is just plot each of these points here to see if they're a solution. So 1, 4, do we right 1, up 4. Okay, that's not within the shade, so nope. 4, 1. 1, 2, 3, 4, right, up 1. Looks like that works. I think. It's really going to be close there. I'm going to be honest, that's a maybe because my graph is too messy for me to tell. If it were dashed, then it won't, but it looks like it kind of falls inside of that. Can't tell for certain. You should be good on the test. I just got a little messy with I want to erase everything. Alright, 4, -7. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7. Okay, that one's obvious no. And then 7, -2. So 7's right here, -2's here. And that's a for sure yes. Okay, so you're just looking to see if those points fall within that shaded area or on the solid line. Again, on this one over here, if it's on the dash, don't count it, but I just can't tell for sure without erasing everything I've done there. Alright. 5. Determine the slope of each line, then determine whether the points have positive, negative slope, 0, or undefined. You will be given the slope formula for this, so it's y2 minus y1 over x2 minus x1. M equals M for slope. Alright, so then you can pick whichever one you want to be y1 and y2. You just have to keep it the same for the x. So I'm going to make this x1, y1, x2, y2. So if I plug in then, y2 is -5 minus y1 is 2 over x2 is 1 minus x1 is 3. Okay, -5 minus 2 is -7. Please use your calculator to be certain on these. 1 minus 3 is -7, or -2, sorry. Double negative does cancel out, okay? So I want to think just 7 over 2, and that is positive. Right? Take a pause, you guys try B. Alright, hopefully you're checking. You should have gotten negative 11 over 0. I think if you did it the other way, you would have gotten positive 11 over 0. So either way, if 0 is on bottom, you can check this on your calculator. If you enter this, you'll get error. Okay, so if it's an error, that is undefined. When 0 is on bottom, that's undefined. If you're on top, it would just be 0. Alright, identify the slope and the y-intercepts of the following linear equations. Okay, you have to put these in slope-intercept form first. So by doing that, I minus 7x from both sides. Y equals negative 7x was a negative 3. Alright, so my slope is negative 7. My y-intercept is negative 3. Alright, take a minute and try B. Hopefully you are checking. I just wanted to simplify it with you. So negative 6 over negative 4x simplifies, those negatives cancel, and it simplifies to 3 over 2x. You could also put 1.5x, but 3 over 2 is easier to graph. And then 24 over negative 4 is like division, so minus 6. Alright, so that gives us a slope of 3 over 2, or 1.5, and a y-intercept of negative 6. Okay, write the equation in your given line, explain how you got your answer. Okay, you want this to be in slope-intercept form. Remember, slope and intercept, y-intercept, hence the name. Alright, so I'm just plugging in here. So I need to still have y and x. Make sure you have x. People tend to forget that one. I think it's easier to pick the b or the y-intercept first, and it crosses the y-axis at negative 1. And then for the slope, you want to pick two nice even points. Well, there's an even point, and here's another one. So I'm going to go 1, 2, 3, 4 right. Write this down. And 1 down. Okay, well, down tells me up or down my y value. So that goes on top. Right is my x, because x tells me left or right. That goes on bottom. And since it was 1 down, you want to make that negative 1, or just kind of stick it in front here. So final answer, y equals negative 1/4 x minus 1. This would honestly, this work here would be enough to explain, but you could just say something like the slope is negative 1/4, the y-intercept is negative 1. Something like that. Okay, Katie has $100 in her savings account and wants to start saving for a new phone. She makes $40 per day. Per is usually a keyword to tell you multiply. Cost her $13 per day for food and $4.50 per parking. If she saves the rest, write an equation showing how much money is in her account after any number of days. Define each variable. It says it costs her $13 per day for food, $4.50 for parking. If she saves the rest, write an equation showing how much money is in her account after any number of days. Okay, so it looks like it wants to define the variable, so I'm going to do that first. Looks like money in her account. I'm going to use money for M. And then D for days. Days worked specifically. Alright, so we're trying to find the money. So I'm going to say M equals. Looks like she starts off with $100. And so it's 100 plus. And then, she's saving 40 per day. So that's like a positive number. Well, if it cost her 13 per food, I want to think of that as a negative number per day. And then a negative 4.5. I can put the 0, but I don't have to, per day. Because again, parking is a cost. All right, we want to now just combine our like terms, right? M equals 100. And if I do 40 minus 13, that's 27. And then minus 450 be 2250. And don't forget D for days. So we're not actually solving this, it just says write an equation because we don't have the number of days, so we can't find her total money amount. So I would just say my equation is M equals 100 plus 22 point, I'm just going to simplify that to 0.5 days times days. Okay, graph the following inequality below. Alright, so there's your slope and your y-intercept. Take a pause and try to do this on your own. Don't forget to, if this is solid or dashed, think about that, and then shade. Okay, this is the line you should have. It is a positive slope, so I want to check that. That is going up. Yes, that's positive. I started at negative 4, and then solid line because it was or equal to. Now this says less than or equal to, so these are my lessers, y values, so I'm just going to shade everything below that. Skip one. Okay, we're good, sorry. Alright. So Johnny cycled 6 miles this week and plans to cycle 5 more miles per week. Remember, that's a clue that you're multiplying from now on. Kathy cycled 2 miles this week and plans to cycle 6 more miles per week from now on. Create a system of linear equations that can be used to represent the situation. So system means we're going to have 2 of them. So I'm just going to say for Johnny, and then for Kathy. All right, so I'm going to put these in slope-intercept form. I'm going to use y for like their total. Johnny's starting point was 6, okay? He cycled 6 already, and he plans to cycle 5 more per week. Remember, if our per tells us multiply, I'm going to do 5 per, I'm going to do x as my weeks, and my starting point, or my y-intercept, would be 6. So take a pause and see if you can figure out Kathy's. Okay, hopefully you got something along those lines for Kathy. If you put, this would work too, as long as you don't put the x with the 2, because that's her starting point. 6 is what's going to be added on per week. All right, so I would say y is the total miles cycled, and x is the number of weeks. All right, represent this system of equations on the graph below. Label your axes and all important information. So we'll just say like miles cycled for my title. All right, I'm gonna have weeks at the bottom, miles on my y. Now I went and tried to graph this and it doesn't quite fit, so I'm going to change the scale on this graph to go by 2s. So it's like 2, 4, 6, 8, and here, same thing. Alright, so I'm going to graph Johnny's in gray here. So we're going to start at 6. And then there's a slope of 5 over 1, you want to think. So that's 2, 4, 5 would be half of 1. And then to the right, 1, which is just half a square. And we'll do it again. So that's 1, 3, 5 over 1. Looks like that's as far as we can go. All right, and then I will do Kathy's in green. Okay. so start at 2 with a slope of 6. So I'm going to go 2, 4, 6 over 1, which is half. 2, 4, 6 over 1, which is half. 2, 4, 6. And can't really fit another here, so I'm just going to connect those. Okay, so I've tried this one a couple times. It honestly doesn't work out well for this graph. Sorry, I didn't realize that ahead of time to fix it on this assignment, but I wanted to still show you how to do the graph so that you have that part for your tests, and it will work out for your tests and match up on there, but still practice doing the graph part. Okay, so I am actually going to just solve this a little differently. I'll show you just a substitution way, but I will say on the test on D, you want the part where they've cycled the same number of miles is just that intersection point on the graph. Okay, so I'm going to do it by substitution. So if Johnny is 5x plus 6, Kathy is 6x plus 2, I can sub this into the y over here. So 6x plus 2 equals 5x plus 6. I would subtract 5x, giving me 1x, and subtract 2 from 6, giving me x equals 4. All right, once I have that, then I can just plug that into either of the equations. So if I plug into Johnny's, that would give me 5 times 4 is 20 plus 6, y equals 26. If I plugged into Kathy's, I would do 6 times 4, which is 24 plus 2, which is also 26. So you want to think what this means. If I'm talking my x value, I'm talking weeks. My y value, I'm talking miles. So after how many weeks will they have cycled the same number of miles? Well, we said 4 weeks from our solution. And part E, how many miles will they have cycled this time, would be 26 miles. All right, so this is like the final question on your test, and it is a lot of points. So if you have any questions on this, please let me know. Again, sorry that graph didn't work out on that, but as long as you understand the process, you should be good, and you can always solve by substitution like I did to kind of check your answer to be certain. All right, I hope this helps you prepare for the test. Don't forget, it'll be either the 5th or 6th, depending if you are a gold or purple day class. Have a great day.